Across much of the developing world, citizens routinely face bureaucrats and public servants who demand small, illegal payments for services they are legally entitled to receive. This chart visualizes data from the Global Corruption Barometer for India. It maps out a massive scale of everyday extortion. For citizens interacting with the police, 42% report paying a bribe in the last 12 months. For basic identity documents, it's 41%. Overall, the baseline bribery rate sits at nearly 40%. You might expect a population subjected to that level of harassment to have zero faith in their legal system. Yet survey data shows that 49% of the population continues to express trust in the government's capacity to enforce laws and punish wrongdoing. So citizens are widely extorted, and half of them believe the government can actually punish the extorters. But when you look at how many people actually file a formal complaint after paying a bribe, the rate collapses to exactly 12%. Academics and policymakers typically try to explain this gap by pointing to a lack of civic duty, broad public apathy, or widespread moral decay. The data rejects those theories. 46% of citizens actively use informal personal connections to bypass corrupt bureaucracy entirely. People are not passively suffering. They are expending time and social capital to navigate the system. The 12% formal reporting rate is a calculated, strategic choice. That 12% figure is a perfect Bayesian equilibrium. Reporting corruption carries a deeply asymmetric risk. If you successfully report a corrupt official, the entire community benefits from a cleaner system. But the retaliation, the bureaucratic delays, and the social friction fall entirely on your shoulders. This asymmetry creates a devastating informational feedback loop. If you expect that your neighbors will stay quiet, speaking up isolates you, drawing all the retaliatory attention. Silence spreads because each individual correctly calculates that acting alone is too dangerous. State enforcement capacity, hotlines, investigators, and tribunals cannot solve this by simply existing. To understand how systemic silence sustains itself, we need to map the mechanics of this interaction using a formal game theory model. We construct a single isolated encounter. A citizen needs a basic public service, and the official sitting across the desk demands a bribe. We start with mu, the probability the official is genuinely corrupt. Consequently, 1 minus mu is the probability the official is honest. The citizen decides to pay or report under incomplete information, observing the demand but unable to see which branch the official belongs to. On the other side of the desk, the citizen carries a variable called theta. This is the private reporting cost. Theta isn't a financial fee. It represents the personal friction of the system, the hours lost filling out complaint forms, the fear of police harassment, and the social stigma of being a troublemaker. Theta is drawn from a population distribution. Some people have high political connections and low fear. Others are highly vulnerable and have massive fear. Every citizen has a unique, hidden threshold they can tolerate. Because this fear is entirely private, the decision to blow the whistle comes down to a strict mathematical comparison. Does the expected payoff of reporting outweigh an individual's specific level of fear? Paying the bribe yields a certain payoff, service value minus the bribe. Reporting offers an expected benefit, probability of punishment minus procedural costs and private fear, theta. To speak up, expected benefit must exceed the certain payoff. Isolating theta derives the system's critical threshold, theta star. Only a citizen whose personal fear level is lower than the theta star threshold will choose to report. This bell curve represents the population's fear distribution. The theta star cutoff drops here, slicing the population into two behaviors. A tiny slice on the left reports the corruption. The massive block on the right finds speaking up too costly and pays quietly. To fix a corrupt system, a government must push this theta star threshold as far to the right as possible, capturing the majority of the population. But the bureaucracy fights back. Honest officials introduce a major complication. They can strategically demand bribes, not out of greed, but to reduce their workload or speed up administrative processes. We define the probability of an honest official demanding a bribe as delta star. This ruins the citizen's ability to infer what is happening. A bribe demand is no longer definitive proof of corruption. The signal becomes ambiguous. This is Bayes' rule. The citizen uses it to calculate mu hat, the actual probability they are facing a corrupt official given a demand. As honest officials increase demands, the signal dilutes. MAHAT shrinks, driving down the expected chance of seeing the official punished. Now we view the interaction from the official's perspective. What drives their decision to demand a bribe? An honest official weighs administrative convenience, G, against the reputational risk of being reported, calculated by enforcement probability, reputational penalty, and Q, the aggregate citizen reporting rate. If citizens rarely report, Q plummets, making reputational risk mathematically zero. The honest official now always demands a bribe. This triggers a catastrophic feedback loop for the citizen. With delta star at 1, the citizen's Bayesian inference is perfectly diluted. The expected benefit of reporting collapses, pulling the citizen's theta star cutoff line completely off the graph. This is the pooling equilibrium. Universal silence occurs not because citizens approve of corruption, but because the math locks both sides into quiet compliance. When governments recognize systemic corruption, what is their default response? They invariably try to boost P, the raw enforcement capacity, by launching hotlines or funding anti-corruption commissions. Looking at the full equation, we can prove mathematically why this approach fails. You can increase the enforcement variable P all you want, but because it is multiplied by the diluted posterior, mu hat, its total impact on the threshold is crippled. The equation is dominated by the procedural cost, CR, and the private fear, theta. These act as severe subtractive drags that raw enforcement simply cannot overcome. If the act of reporting requires waiting in lines, navigating hostility, or risking retaliation, pumping money into state enforcement is an illusion. It will never generate enough leverage to break the pooling equilibrium. The only way out of the trap is to attack the procedural cost, CR. Shrinking the cost removes the mathematical penalty against the citizen. This directly pulls the theta star cutoff to the right, capturing a massive new cohort of low-fear citizens. As these citizens begin reporting, the aggregate reporting rate, Q, suddenly spikes. This breaks the official strategy. When the reporting rate crosses a critical threshold, the honest official suddenly faces immense reputational risk. They immediately stop demanding bribes. This creates the separating equilibrium. Because honest officials step back, a bribe demand now guarantees you are facing a corrupt official. Mu hat equals 1. This maximizes the citizen's incentive to report, pushing the cutoff line even further to the right. To escape a 12% reporting trap, incremental reform is useless. A tipping point must be crossed. True transparency requires destroying the private cost of speaking up. In the architecture of systemic corruption, fear is the primary structural variable.